Good afternoon, everyone, and thank you for a very brief introduction. Just want to say one time, I was really, when I got a call for this talk and for the 25 years of celebration of ATREE, I got really excited because it's a homecoming back. Many of you might not know that I started my career at ATREE in 2011, and then I moved on to Roorkee for the personal reasons. But so it's a homecoming, and thank you, ATREE, for inviting me. The another excitement was that my research group has been really thinking of to give a name to our group, and I am really excited to say that this is the name we came up, and this is the first time officially I am basically bringing out this name. So we are going to call our research group HILLTOP. It basically stands for Himalayan Instrumentation Laboratory and Long-Term Hydrological Pathways Observatories. So I'm going to talk about a very showcase of very few 2 or 3 aspects of my research group, what we have been doing, and how we connect with the research communities in hydrology. So I am not the only one who is basically standing on the hilltop. I have many eyes from my research group who are looking the water pathways from a different lenses. So be it the sediment transport, be it the rainfall runoff mechanism, runoff generation mechanism, or the lake systems. So we as the researchers, we are basically seeing the water pathways from different lenses of the eyes. When you saw the title, it stands for the Himalayan. So basically, my research area has been focusing on the Himalayan ecosystems and Himalayan watersheds, starting from the northeast side towards the western side. So we have been monitoring lots of springs and the river systems, and also the spring systems and the lake system. And these sites are not been basically all done by myself, basically a work of collaboration, starting from ATREE with Jagdish and IHS, and then Chirag, and then Aquadam. So there are lots of people who have really helped me to establish those sites and to monitor and to understand the system. So the group is basically working on different aspects of hydrology and the water pathways, starting from the methods. And we are developing the field instrumentations. We are doing the laboratory-based experiments, modeling, and to understand the different processes, basically. So be it the rainfall processes, the runoff generation, hill slope connectivity. So idea is basically, when Sharad was yesterday mentioning, okay, when we do and generate knowledge, so why are we generating knowledge? So the idea is basically generate the knowledge. We want to understand the science behind the water pathways in this Himalayan system, but also there has to have a relevance why we are doing it. And every part of my research work, we have been keep thinking, okay, why we are doing it. So be it the spring water understanding, so it's mainly towards the water scarcity, what Dr. Deepak basically mentioned just before my talk. And also the sediment transport, be it the climate extremes happening, the debris flows are happening, how the sediments are moving in our high gradient rivers, and also the landslides, rain triggered landslides, what we are happening more in the Himalayan systems a lot. So I'll be just going a very showcase of 4 studies on snapshots of my work, and these are the work which my students have been working, and these are the data sets what we are going to show. Some of the data sets are incomplete. They are the unpublished data which is just coming out from my group, and basically this monsoon season only. So going back first to the mountain aquifers. So why we are talking about the waterscape? So we as a research group, we are seeing the water pathways from different waterscape or different pathways. So one is the mountain aquifer, which basically we started working with ATREE along with Jagdish when we started monitoring those springs in the Himalayan system and what type of responses are there for different rainfall patterns. So after understanding what type of aquifer properties are there, after understanding that, so we moved on to the other aspect. Now, one of my students is working on the signature of the isotopes. Can we use the isotope analysis and find out what are the recharge areas of this system? So we have this is a polygon, which is my experimental watershed, basically, and we have the spring sites, and we have been doing the isotope analysis for these sites to understand where are the recharge areas, how good they are, how complement they are for the hydrogeological mapping. So that's the question we are asking. So the very onset of the data set, this is basically the December and February data set. So what you're seeing here is basically some numbers which are in triangle and they are in the rectangle. The idea is basically, so numbers are the stable isotope percentage which are coming out from the springs, and they are clustering in one side. The story is basically the springs which are closer to the river sides are basically more fed by the river systems here, but there are regions where the spring signatures, the isotope signatures are different, and they are telling that, okay, there is more evaporative processes are also happening in that system. Broadly, all the springs are basically showing the same signature in December and February, and we have all the data sets up to now July. The other aspect, when we move on from the springs, we as a hydrologist can see the water from the sky falling onto a watershed or a ecosystem, be it a pine ecosystem or an oak system. You can see it from the above the canopy site, so which we are doing the work with Jagdish and Jaya Khanna from NICER. We are trying to understand how these two types of ecosystems, pine and oak, how they are basically transpiring the water into the ecosystem and what is the effect of it in the long term. The other work we are doing with the Jeevan Institute in Sadipan Mukherjee, what we are going to show here is when we get the water on the canopy, it partitions. So these partitioned water in the term of Stemflow and Throughfall, we do not really have a good numbers of it in our ecosystem, in the Indian Himalayan system. So we started working on that monitoring. So we have installed the troughs and the stem flows in oak and the pine system, and then we are monitoring it. So the idea is basically to get the numbers out from by 30 meter plot size to get how much the transpiration, the stem flow and the throughfall is happening. Again, a snapshot of the data set. What we have is on the two graphs, the pine, on the y-axis you have the percent stem flow, and on the x-axis you have the maximum 30-minute rainfall intensity. How the intensity and what is the effect of the intensity on the percent stem flow and the throughfall under two pine and oak systems are different. And what we are seeing here is, this is just this monsoon data set, which has some little gaps also. So what we are seeing here is the pine has a lower stem flow percentage conversion as compared to the oak side. And when we go to the throughfall, is a similar numbers. What we have here is we have around 63% of the throughfall, the rainfall is converted into throughfall in the pine side. 66% is basically getting generated. But just make a point here is that this data set is basically from the monsoon type. Now, if we go to the seasonal data sets later on, it will be a very different story. So we are looking forward to have those type of number, but from the Waterscapes point of view, it's basically you can see the water partitioning in a different ecosystems at different sets. So another aspect of our research group, we are, after the water starts moving in, we have partitioning, the water starts flowing into the rivers. It eventually goes to the nearby water body. So the water body could be your lake system. So what we are doing here, the work is again, and as I said, like ATREE is my homecoming. So whenever I have some questions, I normally pick up the phone and call my colleagues at ATREE. For this, basically, I called Veena because I knew Veena was working on the lake system. Because the idea is we established this buoy system, and I think this is one of its own kind. It is a real-time buoy with the water quality parameter at 4-meter depth right now, with different water quality parameters. And what we are doing from the last 1 year is we are basically monitoring weekly the water quality parameters in the lake at 8 locations longitudinally. And what we are seeing here is basically the 1 year data set, just one part of it, the DO part. what you are seeing here is basically the lake system is well homogenizedly, like it's well mixed. But it is because also there is a aerator, 24/7 aerators are going on to aerate the system. The question here is how good they are, how good or what will be the effect of these aerators on the ecological system. When we talk about the lake system, so it's like ecosystem, right? It's not only the water which has been used by the human, but also there are fishes and there are plants. So what is because in general the natural lakes they do turnovers. So there is a time when you have an anoxic condition and then you have a turnover system going on. So what will be the effect of these aerations? So those are the different questions which we will be asking in a long term. And idea is to basically develop the hydrodynamic model for the lake system and then see how can we use for the different scenarios. The last part, what I'm going to talk about is the high gradient rivers. As we all know, we are sitting on the Himalayan system, not here, but my state. So we have a lot of high gradient rivers which are flowing through our systems. So this is one of my, the first part when I showed is about this Paligad, when I was showing about the spring. But this is the whole catchment is called Aglar watershed, which is one of the main tributary to Yamuna, just behind Mussoorie region. Here what we are trying to understand is how these high gradient rivers basically carrying the sediments. Why we started thinking of this question is when we are talking about the sediment, in CWC also, we do not have specific numbers or the way to measure the bed load. And bed loads are, in general, in the CWC modules also, we still go with only 15% of suspended sediment. But there are ways now which are being picked up in other side of the countries where we can basically estimate. And one of the idea is basically to quantify that, because every time we are thinking and we are hearing that reservoirs are getting sedimentation is happening, we are losing the carrying capacity. So the idea is basically to develop a methodology, to develop a model to basically get this bed load estimation. What you are seeing here is a tracer method. Basically we do. We painted the sediment, the bed loads, and over the time we go back and we see what is the mobility of the system. And using some of the empirical equations, basically we develop the shear stress mobility of the partial system and the fully mobility condition. Then you go with the some of the bathymetry data sets. Eventually the idea is to basically develop a velocity component at the bottom to get the velocity number of those high gradient rivers. Using that, we can develop the bed load estimation. So what you are seeing here on the bed load, on the y-axis is the rate of bed load, kg per meter per hour, and based on the shear stress, what that river has it. So idea is to basically get the number out for the different type of high gradient rivers, and then basically use it for the overall suspended bed load transmission. What we have found out is it's not only the velocity, it's also the type of material the rivers are carrying. And so basically what you saw previously, Aglar is the main river and Paligad is the tributary. But Paligad has a very high rate in terms of bed load. But as compared to the quantitative amount, cumulative amount, is Aglar is carrying more sediment bed loads from it. And the types of the sediment it's moving is basically very different. In Paligad, we normally have a round shaped sediment. As compared to the Aglar, we have more of the flaky type of elongated systems. Then, so idea is basically to give you a very screenshot and the showcase of my work, what we have been doing, starting from the aquifer system to the different ecosystems in forest, and then lakes, the Himalayan lake system and the river system. Because you can have a different eye views, different lenses to see a particular waterscape from different sides. The question still remains the same, and I have been hearing this word and the caution in overall yesterday and today also. We are doing research. We are trying to develop some new models, new equations, and so idea is basically, okay, we do understand and we are developing it, but how do we translate it to the policy and practice? And that's where I still feel it is still, ATREE is very, very strongly stand out, and our interdisciplinary work needs to be there, because every time we do a science, but how do we really take it to the policy and practice? That is still a challenge for me and my group, but I still look forward to work with pretty much everyone who works in the water area to take the results out to the policy and practice. Just give you a last example of it, how it can be done. Working in Springs for almost 6, 7, 8 years now. So the way the people started, the way Dr. Deepak was talking about, it's more of the community-based participation and all. That's the way it has to go. No national level or state level can implement. But in India, when the previous national water policy was there was no word of spring basically being mentioned in those water policy. But this current water policy has a word of water springs there, and there is a lot of takers of springs. The groundwater people are talking about springs. Central Water Commission is talking about springs. So there is a way out. Yeah, it takes time, but yes, the policies can be modified, and your work will see a light of the day. And I think that's a very positive part of the springs. So it has taken maybe a lot of people who have worked previously, myself, like Himanshu Kulkarni and lots of people who have worked in springs have seen a light there. So there is a way, but I think, yeah, a lot of work needs to be done in terms of policy and practice. I'll stop here. Thank you very much.